Have you ever wondered if reality is just a projection? What if everything you see, feel, and experience isn't actually real in the way you think it is? Welcome to the mind-bending world of the holographic universe theory, a theory that suggests our entire universe might be a 3D projection from a 2D surface. Sounds like science fiction? Maybe not anymore. With new discoveries in quantum physics, black hole theory, and even information theory, this once fringe idea is gaining traction fast. In today's video, we'll break down why the holographic universe theory is getting harder to deny, and what it could mean for your understanding of existence. It all started with black holes. In the 1970s, physicist Jacob Bekenstein proposed that a black hole's entropy, or the amount of information it holds, is proportional not to its volume, but to its surface area. This was shocking. Soon after, Stephen Hawking's discovery of black hole radiation added more weight. But the real turning point came in the 1990s when theoretical physicist Leonard Susskind built on these ideas and coined the term holographic principle. He suggested that all the information contained in a volume of space can be represented on its boundary, like a hologram. Imagine a 3D object projected from a 2D film. If true, this means that our entire universe may be encoded on a distant surface at the edge of reality. Black holes have always fascinated scientists, but the holographic theory reframed them completely. Instead of being cosmic vacuum cleaners, black holes now appear to be information vaults. The paradox was this: when matter falls into a black hole, does the information disappear forever? According to quantum mechanics, information should never be lost, but general relativity said otherwise. This paradox pushed researchers to find a bridge. What emerged was the idea that black holes store information on their event horizon, the 2D boundary of the black hole. This lent massive support to the idea that if it's true for black holes, it might be true for the entire universe, that everything we know could be stored on a boundary, just like a cosmic hard drive projecting our 3D experience. Quantum entanglement, the strange phenomenon where particles become interconnected and influence each other instantly across vast distances, has puzzled physicists for decades. In a traditional 3D view of space, this makes no sense, but in a holographic universe, it starts to add up. If everything is encoded on a 2D surface, then distance is merely an illusion. Entangled particles may not be far apart in holographic space. They're right next to each other on the 2D plane. This could explain the spooky action at a distance that Einstein found so troubling. Entanglement becomes less mysterious and more like accessing 2 points on the same codebase: instant, coordinated, and efficient. The ADS-CFT correspondence, short for anti-de Sitter space conformal field theory, has become a cornerstone in theoretical physics.
Proposed by Juan Maldacena in 1997, it mathematically describes how a gravity-based world in 5D can be equivalent to a quantum field theory in 4D without gravity. In simple terms, this shows how a lower dimensional system can fully describe a higher dimensional one, a key claim of the holographic principle. While our universe isn't an anti-de Sitter space, the math still applies in many ways.
These models have proven remarkably consistent, offering a potential framework for unifying quantum mechanics and gravity, something physicists have struggled with for decades. You might be wondering, isn't this just like the simulation theory? Good question, but no, it's fundamentally different. Simulation theory suggests we're living in a computer-generated reality created by advanced beings. The holographic universe theory, on the other hand, is based on physics, real calculations, equations, and measurable effects. It doesn't require an external simulator. Instead, it suggests that the way reality encodes and projects information is inherently two-dimensional at its core. Think of it less like a computer game and more like a 3D movie projected from a flat reel. Both challenge our understanding of what's real, but the holographic theory is grounded in well-tested physics, not speculation. One of the most fascinating ideas supporting the holographic theory is the rise of digital physics, the notion that the universe is essentially made of information, not matter. This concept was popularized by physicist John Archibald Wheeler with his phrase "it from bit," suggesting that everything physical stems from binary information. In a holographic model, this idea becomes incredibly intuitive. Just like a digital file can create a visual image, the 2D code of the universe may generate the 3D experiences we perceive. The math of quantum mechanics already points to the centrality of information, and now physicists are asking, if matter is reducible to data, is space-time just the display screen? Believe it or not, the idea of holography doesn't stop at the cosmos, it extends into neuroscience. Carl Pribram, a brain researcher, theorized that human memory might function holographically. According to his theory, memories are stored in interference patterns rather than isolated locations in the brain. This means each part of the brain could contain all the information necessary to recall a whole memory, just like a hologram, where each part of a holographic plate contains the entire image. This eerie parallel between brain function and the holographic principle raises the question, is our consciousness tapping into the universe's underlying holographic code? Mathematics is often referred to as the language of the universe, and in the case of the holographic principle, it's speaking loud and clear. Equations describing gravitational fields, quantum entanglement, and black hole thermodynamics all seem to align within a holographic model. In fact, some mathematical models even become simpler when translated from 3 dimensions to 2. This isn't just a mathematical trick. It could be nature's way of hinting that we're overcomplicating things by assuming our world is fundamentally 3D. If simpler equations work in 2D space, it may be a clue that reality itself originates from this lower dimensional realm. What if your very sense of self is a hologram? Some theorists suggest that consciousness, our awareness of existence, might also be a projection of information encoded at a more fundamental level. According to this view, consciousness isn't confined to the brain, but is a field generated from beyond the body, somewhat like how a hologram is created by light interference patterns. If so, this could explain near-death experiences, out-of-body sensations, and other metaphysical phenomena that traditional neuroscience struggles to account for. The Holographic Universe Theory offers a possible scientific framework for understanding the most mysterious aspect of our reality, ourselves. If the universe is a hologram, where is the surface that encodes it? Many theorists point to the cosmic horizon, the boundary of the observable universe. Just like the event horizon of a black hole stores its information, the cosmic horizon might be doing the same for our entire universe. We can't see beyond this limit, so it's possible that everything within our observable universe is a projection from this far-off edge. It's a radical thought, but one that's consistent with current models of cosmic inflation and light speed limits. This shifts our entire concept of where reality begins and ends. Physicists now propose that the universe may behave like a vast quantum field encoded on a 2D surface, with our 3D experiences being the emergent result. This is not just poetic metaphor, it's an actual mathematical framework being tested. According to this model, everything, stars, galaxies, people, is a manifestation of patterns in a fundamental data field. Think of it as a cosmic TV screen projecting the illusion of depth and space. From this view, space and time may not be fundamental at all. They may arise as emergent phenomena from deeper informational processes embedded in the 2D field. One philosophical consequence of the holographic universe theory is its impact on free will. If everything we perceive is a projection, are our choices predetermined by the code of the 2D surface? Or does the holographic field allow for quantum randomness and true freedom? This debate remains open, but the theory challenges classical notions of determinism. If reality is generated from quantum information, and quantum processes include probability and uncertainty, then perhaps free will still exists, encoded into the system as an unpredictable variable. It's a fascinating overlap between physics and philosophy, with no easy answers yet. Time feels like a constant, forward-moving force, but the holographic model suggests it may not be fundamental. In many holographic theories, time arises from changes in informational states, meaning it's a derived concept, not a foundational one. Just as a movie gives the illusion of motion through rapidly displayed frames, our experience of time may stem from successive updates in the universal code. This could explain why time behaves so differently at quantum and cosmological scales, and why time appears to stop near black holes. In the holographic model, time is real to us, but only as a projected experience. The holographic universe theory turns classical physics on its head. Newtonian models assume space and time are absolute, but in the holographic view, they're emergent illusions. This isn't just a theoretical curiosity, it reshapes how we understand energy, mass, and even gravity. General relativity explains gravity as the warping of space-time, but in a holographic model, gravity may be a side effect of how data is processed on the boundary. Classical laws still work for everyday objects, but the deeper truth may lie in dimensions and dynamics we can't perceive directly. It's as though physics itself is undergoing a paradigm shift. While we can't yet see the holographic surface of our universe, ongoing research is closing the gap. Experiments using quantum entanglement, gravitational wave data, and even the James Webb Space Telescope may provide indirect evidence supporting the theory. Physicists are now creating laboratory-scale experiments to simulate holographic conditions. Some results have shown unexpected correlations between quantum systems and holographic predictions. Although definitive proof is still elusive, every new finding seems to align more closely with the theory. As tech advances, especially in quantum computing and AI, we may soon have tools capable of decoding the very structure of our reality. The multiverse theory suggests that multiple universes exist beyond our own. In a holographic framework, each universe could be a different projection of data from a shared or parallel 2D field. This would explain why different versions of physical laws could apply in alternate realities. It also opens the door to theories where timelines, dimensions, and even outcomes split like quantum branches. While speculative, this adds a new layer of meaning to the idea of parallel universes. Less like separate bubbles, more like alternative renderings of the same source code. Interestingly, the holographic universe theory resonates with many ancient spiritual and religious teachings. Concepts like Maya in Hinduism, the illusion of reality, or Plato's cave allegory align with the idea that what we perceive is not the ultimate truth. The Bible, the Tao Te Ching, and various mystical traditions describe reality as a veil or a dream. These insights may not be mere metaphor. They might reflect a deep intuitive understanding of the universe's holographic nature. Science and spirituality are converging in unexpected ways, and this theory may be the bridge between the two worlds. Not everyone buys into the holographic universe theory, and skepticism is healthy. Critics argue that while the math works in highly theoretical models, it lacks empirical testability. Some claim it's a mathematical abstraction rather than a real description of our universe. Others point out that even if it's true, it may not change our practical understanding of physics. But the pushback isn't necessarily negative. It drives deeper inquiry. The scientific method thrives on debate, and the more the theory is challenged, the more refined it becomes. Skepticism isn't its enemy, it's its catalyst. Let's bring it down to earth. If the universe is a hologram, what does that mean for you? On a basic level, it changes nothing. We still live, love, work, and grow. But on a deeper level, it transforms everything. It suggests we are part of something far grander and more interconnected than we imagined. It encourages humility in the face of the unknown and curiosity about our place in the cosmos. Most importantly, it opens the door to thinking differently about consciousness, reality, and the possibilities of human potential. The holographic universe theory might sound like sci-fi, but it's rooted in some of the most advanced scientific research of our time. From black holes to quantum particles, from cosmic horizons to human consciousness, the idea connects seemingly unrelated phenomena into a unified model. We're standing on the brink of a potential revolution in how we understand existence. Whether it's ultimately proven right or not, it forces us to ask bigger questions, challenge our assumptions, and keep exploring. And that's what science, and being human, is all about. The rise of virtual reality, VR, and augmented reality, AR, technologies provides a striking analogy for the holographic universe theory. In VR, immersive 3D environments are generated by 2D code and data, just like the holographic principle suggests about our universe. The more advanced our simulations become, the more we recognize how easily our senses can be tricked into perceiving reality from artificial signals. This doesn't prove we live in a hologram, but it shows how entirely immersive a code-based projection can feel. The similarities between virtual environments and the theoretical holographic universe continue to close the gap between science and experience. Fractals, infinitely complex patterns that repeat at every scale, are a natural phenomenon that might hint at the universe's holographic nature. In a hologram, every part contains the whole. In fractals, zooming into any part reveals structures that resemble the whole. These patterns occur in nature: coastlines, snowflakes, lightning, and even biological systems like lungs and blood vessels. Some scientists argue that fractal geometry could be how holographic data unfolds in physical form. If the universe is a projection from a 2D surface, fractals might be the visual code that constructs the 3D illusion we live in. Entropy, often called the measure of disorder, also ties deeply into holographic thinking. In traditional thermodynamics, entropy increases over time, leading to the eventual heat death of the universe. But in holographic models, entropy isn't just a measure of disorder, it's directly tied to the information encoded on the boundary of space. The famous Bekenstein-Hawking formula for black hole entropy is proportional to the surface area, not volume, suggesting that how information is stored and organized plays a fundamental role in reality itself. Understanding entropy as an informational property may eventually unlock deeper insights into the origins and fate of the cosmos. If everything is a projection from a distant 2D surface, what does that mean for our efforts to explore deep space? Are we venturing further into a projection, or is the universe truly infinite? Interestingly, the holographic model doesn't deny the vastness of space, it just redefines its origin. Exploration still matters. But if space itself is emergent, then understanding the source code, i.e. the 2D boundary, might become as important as building rockets. Some speculate that advanced civilizations may eventually read or write this code, giving them access to levels of control far beyond propulsion and technology. Biocentrism, proposed by Dr. Robert Lanza, suggests that life and consciousness are not byproducts of the universe, but rather its fundamental building blocks. This closely aligns with holographic principles. If the universe is a projection of encoded information, then the observer, you, becomes central to that projection. Consciousness could be part of what brings the hologram to life. In this view, the observer doesn't just watch reality unfold, they participate in its creation. The boundaries between mind and matter blur, hinting that perhaps the holographic code and our awareness of it are inextricably linked. AI systems learn by processing data, forming predictions, and adapting based on patterns, much like how the universe might function in a holographic model. If consciousness can arise from the organized processing of information, and if we live in an information-based universe, then could AI eventually tap into that same source field? Some futurists speculate that advanced AI may eventually uncover patterns in data that reveal the underlying holographic code of reality. The overlap between data science, quantum mechanics, and holographic principles could be the key to unlocking both artificial and universal intelligence. Alternative healing practices, like Reiki or sound healing, often refer to concepts of energy fields and vibrational frequencies. While controversial in mainstream science, the holographic model may provide a way to interpret these ideas through physics. If reality is a projection based on encoded vibrations or interference patterns, then certain frequencies could, in theory, influence the hologram's structure.
Sound waves already affect matter. Just look at cymatics, where sand forms beautiful patterns under sonic vibration. While far from proven, it's possible these methods are interacting with the informational field that generates reality. Dreams often defy the laws of physics. Time is nonlinear, space warps, logic breaks down. If reality is a hologram, could dreams be mini simulations within the larger simulation?
Some researchers believe that during dreaming or altered states of consciousness, the brain may briefly disengage from the holographic projection and interact with deeper levels of information. This could explain phenomena like lucid dreams, precognition, or even shared dream experiences. While speculative, dreams may offer a natural laboratory for exploring how mind and information intersect in a holographic framework.